All right, hello again. Before we carry on with how to create a consequent pole, I would suggest that for those of you who are just kind of tuning into this sort of lesson, that you stop and go back and, excuse me, listen to the short presentation on creating a conventional pole. I believe it's important to understand that first before you take this on. Okay, now having said that, after watching that video, now what we're going to do is we're going to create a consequent pole, and what that essentially does is this. We want now, instead of current to flow the same direction around each pair of poles like we did in the previous experiment or the previous demonstration, we actually want it to flow in two opposite directions. And again, we are going to make either a series or a parallel connection to do that. Remember, when I say we, I really mean the starter does that for us. Okay? So the starter, when we hit that start button for high, it's going to create one speed, and when we hit the start for low, it's going to create a different speed, and that speed will be half of the synchronous speed of the high. So here's the deal. First, again, we have to evaluate how are each one of these wound. Here you can see on the top that we're wound clockwise, and the same thing down below. We are wound clockwise. So if I make a series connection here, again, just like we did in the previous demonstration, what we'll end up with is one north and one south pole. Our goal here is to create current flow that travels two different directions. So in order for that to happen, we have to make a parallel connection. So just like we did in the previous demonstration, we're going to connect here, and we're going to terminate, and then we're going to go like this, and we're going to terminate this guy. And we're going to freeze frame that AC sine wave for a fraction of a second, and we're going to assign a polarity of negative there and positive here, and we're going to look at electron flow. Electron flow, again, is always from negative to positive. So I'm going to switch colors here to show electron flow, and let's see what happens. So here we go with electron flow traveling this way. Again, we reach a junction point. Now at this junction point, this is where our current splits. So we have some current that's going to flow that direction and some current that's going to flow that direction. Let's follow it around. So it goes in behind here. That means we have current like this, which means we're counterclockwise up top here. Let's follow it on the bottom. Well, now, because we've made that parallel connection, now as you can see, we have currents going the opposite direction. Down here now it's going clockwise. So once again, we use the left-hand rule for coils, not conductors, left-hand rule for coils here, and we have to determine where's my north rather and where's my south pole. Well, with the left-hand rule for coils, that means we end up, oh, there I go again, wrong color. Let's X-nay that here for just a second. We want to use black here. Anyway, we end up with the north pole up here, and we end up with a south pole right there. Now let's look at the bottom. Well, on the bottom now, using the left-hand rule for coils, we end up with a north pole here and a south pole here. Now if you guys recall, when we have two magnets put end to end and they're the same polarity, those two magnets are going to repel each other. The result, or as a consequence, and this is where the name came from, as a consequence of causing current to flow in two different directions, we ended up with two like poles in the armature region. The end result of that, or the consequence of that, is we create two additional magnetic poles. Okay, so now we have a north and south here, and we have a north and south here. And if you guys recall from understanding your rotational frequencies as far as mechanical versus electrical, if I add a set of poles, that is going to cut my speed directly in half. Now again, the speed we're cutting in half here is the synchronous speed. Do not confuse that with the full load speed. Let's take a look at the one on the right. So the one on the right over here, this is the one where we have one coil that's wound clockwise and the opposite down here. So this one we actually are going to make a series connection. So again, the series connection is, by the way, already pretty well made right here. In other words, this is one winding, so it really already is in series. We're going to apply negative there, again freeze framing that AC sine wave for a fraction of a second, and we're going to assign a polarity of positive there. Okay, now I'm going to change colors once more, and we're going to follow current. So current starts out here, and as you can see, we end up with a clockwise direction of current on the top. However, when we follow this current around, and it comes in behind here, you can see we end up with current flow going the opposite direction here. So now we go back to using our left-hand rule for coils, and doing that we create a north pole down here and a south pole up here, and on the bottom our north pole ends up right here, and then our south pole is down the bottom. Once again, as a consequence of two like poles being placed across from each other in the form of an electromagnet, as a consequence rather, we create an additional north and an additional south pole. And of course that again will cut our speed in half. So, a review. In order to make a consequent connection, we have to make sure that the starter will produce current flow in two different directions. As a consequence of this, that will create two additional magnetic poles, which in turn will cut our speed, synchronous speed that is, directly in half.